Hi everyone, in this video I'm going to talk about user-defined functions in R. Now we have seen some functions in R that are built in with R. For example, the min function. If I take the min of a vector like 1, 2, 3, I can get the results. This is an example of the built-in functions in R, which takes some R objects as input and then conduct some operations and then return us the intended value. What if we need to achieve some specific goals and we don't find any functions in R that can do the job? This is where user-defined functions can be very useful. We can write our own version of functions to perform specific tasks. This page is my course website, R Basics section. If we scroll down to 9.4 section, we will see the user-defined functions. We already know the definition of a function, which takes arguments as input and runs specific actions on those inputs and then return the final results to us. The syntax for writing user-defined functions is as follows. Let's decompose the code block here. We first need to use a function called function to define a user-defined function. Sorry, it's a bit tongue rolling, but let's have a look here. I can first call a function. As you can see, function is a built-in function in base R, and within that parenthesis, I can put arguments. There are different ways to put arguments here. These arguments can be thought of as variables, input variables. After we have defined these functions, when we call our user-defined function, we will need to specify values for these arguments. But when we write the function here, they should be treated as variables. We can also put some default values for the arguments. Here I will use an example of computing net present value of a cash flow in n years. To do this calculation, I have some inputs, the cash flow I get in the future. I should also need the discount factor, k, and I also need the number of years. These are variables I need for the calculation. After that, we need a pair of curly brackets. So I can put curly brackets here and then hit enter to separate them into different lines. Now in between, I can write the operations. The general syntax here, we can write the actions to be done with argument 1 and argument 2. So how would you perform your actions based on these variables? In my case, if I would like to compute the net present value of this cash flow, I have this cash flow and I have to discount it by 1 plus k because it's after n years, so I need to take the power to n years. This will be the specific actions I need to perform based on the input variables here, these input arguments. And we can assign this formula to a new variable inside of the function called net present value. And finally, I need to return the value. So when I call this function in the future, given any specific values for CF, K, and N, this formula will give me the net present value of that combination of numbers. I need to return it using this return function also from base R. Return this new variable called NPV. Now I have user-defined functions defined. To call this function in the future, I need to give it a name. And the naming rule is just like naming any variable or any R objects. I can call it calculate NPV. And I will use R's assigning sign to assign this whole user-defined function to this name, such that in the future, I can use this name to call the functions. Let's run the code block. You will see that in my R environment, I now see this function called calculate NPV. And the function takes 3 inputs. The first argument should be cash flow, second argument is the discount rate, and the last argument is the number of years. Once this function is defined, I can now call it. To call it, just like any built-in function, we type the function name and parentheses. Now we need to supply the values of arguments in the same order as we define this function. If I talk about cash flow, £100, and the discount rate is 0.1, 10% for each year, and let's see, after 1 year. In other words, I'm looking at the net present value of £100 I can get in 1 year with the discount rate 10%. And the net present value is this value. And on the website, I have another example. I create a function called magic. This function takes 2 arguments, x and y. These are variables. What it does is that inside the curly brackets, I'm taking the square of x and then add y to the square of x and assign it to a new variable called results. Finally, I return results. Then I can call the function. If x is equal to 2, y is equal to 3, I get 2 to the power of 2, 4 plus 3, which is 7, exactly the answer I'm looking for. From these 2 examples, now you should know how we can write our own version of function, a user-defined function. And there are some points to note here. First is about argument. We can set default values for our user-defined functions using this syntax. When we write down the arguments, we can put a equal sign, and right after the equal sign, we can put the default value. In the future, when we call this function, for arguments with default values, if we don't specify any value for that argument, then the function will use the default value to fill in that missing part. Let's see an example here. I'm redefining magic using a similar syntax. The only difference here is that now I give default values to y equal to 1. This means if in the future when I call magic function and I don't supply the value of y, it will use 1 as the default value. Here is an example. I'm calling this function magic, but I'm only supplying the first argument for x. I didn't supply the value of y as the second argument. So when it does the calculation, it will use 1 as the default value for y. Therefore, we see the value of 5, which is square of 2 plus 1, we get 5. Then, what if we don't put any default arguments for a function, but we are missing some arguments when we call the user-defined function? It will throw an error. In this case, I didn't put any default values for y. When I call the magic function, I'm also missing the y's value, so it will throw me an error. Argument y is missing with no default. Next, the order of arguments. In this case, I'm swapping x with y, so now y comes first and x comes second in this parenthesis here. When I define the function, define the operations, it's still the square of x plus y. But when we call the functions, we need to be mindful of the order of arguments. Now the first argument represents the value of y because this is how we defined it. This is the reason why we see 7 as the outcome, because now x takes the value of 2, x squared is 4, 4 plus 3 is 7. So from this example, we see that the order of arguments matters here for user-defined function. Next, about the returned values. right above, I introduced that we can use this return function to output the object we want to use as the outcome. This is the default syntax. However, we can also not use this return statement. If we don't have a return statement within a user-defined function, then it will by default output the last step in the function as the returned outcome. In this case, magic is defined as x plus y. I didn't use any return statement, and we see the results is 5 because the last line of code within the curly brackets will be treated as the outcome. And the final note about user-defined functions is variable scope. In this example here, we see that we have created this new object within this user-defined function. This result is assigned within this user-defined function. However, any objects newly created inside a user-defined function will be local to the function. Local means this variable will be created only within this user-defined function, and we cannot access it outside the function. In this example, I have defined magic, and there's an intermediate object called result. If I want to print out the value of result, I don't see any outcome, and there's an error, result not found. Again, this is because result, this variable, is created within the function. It does not exist in our R environment. And at the end of the video, I would like to share with you some tips on how you can troubleshoot your user-defined functions. There are advanced ways to do the troubleshooting, like using the debugging tools in RStudio, but that's not very friendly to beginners. There are actually some practical tips on how we can debug a user-defined function. Now on my screen, we can see a very complicated user-defined function, which is taught in my Week 2's class about how to compute customer lifetime value for Marks & Spencer. The function takes all these arguments as input. Based on these inputs, we compute the cash flow in each month, the variable marketing cost, as well as applying the retention rate and the discount rate in order to get that final CLV. This is a pretty long function. How can we make sure everything is correct? The first tip is that once we have written all these arguments, we don't need to use them all at once. We can actually define the function gradually, row by row. For example, I can simply delete the remaining lines here, and I'm only left with this capital M, this cash flow in each month. Then I can return this M, temporarily defining this compute CLV to return M. If I run this code block, and if I run compute CLV, can I get the expected result? If yes, it means at least this line of code is correct. Then I can continue to the next line. So I can do from the second step, small c. Each time I just add one more line back to the user-defined function, and gradually I should be able to figure out which part goes wrong. And a second tip to make sure you have written the user-defined function correctly is you can also do the calculation manually. Then you should get the correct result. Once you have defined the user-defined function, use that function to compute the CLV. You can compare the two values. If you see the same values, then likely your function is correct. Otherwise, you may have to follow the previous tip, isolating each step and make sure each step is correct and go to the next step. So this is some general tips for how we can do the debugging. This is all I would like to share with you about user-defined functions. With this knowledge, you should be able to write your own user-defined functions now to perform specific tasks, like computing CLV for any specific scenario or perform more complicated tasks. Happy coding and bye for now.